everyone, welcome back to our YouTube channel Becoming a ROS Developer. Today we've got Yousef, who has just completed the course Linux Basics, and he will be giving us a presentation on that. So without further ado, I will now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Yousef.
Thank you, Mr. Mugova, for this introduction. I'm excited to begin my presentation, and I hope you to find it insightful in addition to the viewers as well. Let's start with running the code, the obstacle avoidance code on the real robotic, which is Turtlebot.
All right.
I am online, okay? Okay. Okay, let me run the robot interface now.
Okay.
It is ready. Okay, let's move next to the obstacle avoider.
All right.
Algorithm. Okay, there's no numbers. In addition to that, we can run the robot statistics as well. We can see now the sensor robot, and we can see the different status of the robot from the front to the right. Let's say front, there is a front left, there is a front right. In addition to that, we can see left and right, etc., with the distances that the sensors are reflecting to us.
All right.
Now we see the threshold as 0.3, which is 30 centimeters.
May you please enlarge that?
Okay.
May you please enlarge the window that's showing the robot moving so that...
Okay. Is it okay?
You can drag it down, so maybe move it a little bit more to your right. Yeah. Okay, that's better. Yes.
Sorry.
Okay, that should be fine. Yeah. Okay, you can go on.
Okay, we can see that the current state is turning left. Set parameter successful. So it is moving on again. Let me see other part, which is the statistics. Okay, the robot is moving again, and as we can see, the robot is acting as we expect from the code, from the obstacle avoider algorithm. Is avoiding the obstacles in his way, and it selects the optimum path and so the safest path to move on. For sure, it is slow because the algorithm is made in this way to make things clear for the student and the viewers. Okay. So now regarding the statistics, we can see the different values in front of us, the distance covered starting from running the script,
yes,
the current direction, we can see it. We can see the odometer position, X, Y, and Z,
Mm-hmm.
for sure, based on the reference that we started this robot from. In addition to the odometer orientation, which includes the roll, pitch, and yaw.
Mm-hmm.
In addition to that, we can see the angular velocity and linear acceleration as well in X, Y, and Z.
Mm-hmm. All right. This is good.
So I think the live demo shows that the code is working as intended.
True. Yes. Can you now walk us through the code itself and explain how you did it? Yes.
Can I turn off this real robot now?
Yeah, you can disconnect. It's fine.
Thank you.
All right.
Okay, let me. Okay, obstacle avoider dot bash. Here we go. This is the obstacle avoider dot bash script.
All
okay.
Right. Can you maximize that so that we can?
Sure. Okay.
All right. Yep.
Yeah. Here we go. We can see the different sections of this algorithm or this program that includes the initialization in the first. We can see the sourcing the robot functions.bash, in which we can include the different functions, getters and setters that are included within robot functions.bash. After that, display the startup messages to guide the viewer to or the user of this application or program, let's say. After that, we initialize the robot to make sure it is stopped in the beginning for safety issues. So set the velocity linear and velocity angular to 0. After that, we set the threshold to 0.3 meter. Okay, after that, we can see that we work with different, we scanned the different and we got the different values that we want to do from the different sensors of this robot through scanning left ray range, left ray front left, front ray, front right, right ray, all the possibilities that is used to get distances that we can benefit from it to decide our safest path are considered in this program in order to determine the free path, for example, and to avoid the obstacles in the paths. Okay, after that we calculated, for example, let's say let's take this one, front left range if greater than the threshold. In this way, we will return the Boolean value. If this is greater, then we will return true, for example, in this way, and this is what actually occurs.
Okay, all right. So if it's true, your robot can keep moving forward. Is that right?
For sure, yeah. It is not blocked; it's free, so the robot can keep moving.
Okay, all right. And I see you only chose to
use. This is a sensor report, yeah, that shows the output. After that, we handled all the 8 scenarios mentioned within the project. Let's take the first case, all front directions blocked. In this way, what will occur?
Okay.
If the front directions blocked, the robot will select either the left or right based on the more safest way. Depends on the distance. It depends on the free distance in front of this, or in that direction specifically.
Okay. And how did you choose the values or for which you set the angular velocity there? Were they just random values?
It is. You mean for set CMD velocity angular,
Yes.
for example?
Yes.
Okay, we are talking about yes, it is random values.
Okay.
I tried many values, and this value was suitable for me in this program.
Okay, and you chose to use only 3 sectors because I see you've only front left, front right, and then front right.
Yes.
Okay, all right.
Until we reach the case A, all clear, we can move forward as we expect, and we do not forget this destination to move. We reduced the threshold to take into consideration the safe path and the safe to avoid the let's say blocked areas in front of this robot.
Okay, all right. So the separation between your 3 sectors, did you just pick 3 or you could have picked 5? How did you determine to use only 3 sectors, to say front left, front right, and just front?
I selected 5. I selected front left, front right, and left.
Okay, it's only when the robot is making the decision of which direction to move that you only consider 3. Is that right?
Yes.
Oh,
it depends. Yeah.
It depends on which direction it is more inclined to be facing at that point.
For sure.
Okay.
Sure.
All right. I see.
And with more distance in that direction, we can decide to which direction this robot will move.
Okay.
Yes.
Okay. All right. I see. All right. So this was the obstacle avoider. Can you take us through the statistics script now?
Yes. Let's move to robot statistics as well. In this code as well, we can talk about the initialization part, the same as the obstacle avoider. We can see here to handle the Ctrl+C gracefully, we used the trap. We showed some messages to the user of this program. We started capturing the initial position of this robot, let's say X and Y. We saved them to compare the next status of this robot with this location and with these coordinates. And we can see the infinite loop to collect and print the states and the different states of this robot by output the current odometer position, X, Y, and Z. Also, we calculated the distance covered using Euclidean distance that is to us. And the reference, as I mentioned, is the first captured position that is mentioned before. In addition to that, we calculated and we showed the orientation from odometry as well, represented by the roll, pitch, and yaw. After that, we calculated and we showed the angular velocity, the linear acceleration of this robot that helps the viewer of this program to troubleshoot what is occurring on this robot and what the robot status at certain point of time.
Okay. All right. So you spoke about using trep. Can you explain in more detail what that command does at the very top?
Sorry, again, which command?
At the very top, the statement with the trep, right?
Trep equals script terminated by user exit 0.
No, I don't think that's the one. Can you scroll down a little bit? Where is that? Oh, okay. I can't find it anymore. Okay, no worries. Okay, another question that I would like to ask you is, every time you make use or you do some form of calculation, right, you you have to put the calculation, and then after that you put a pipe, and then BC, and then the flag L. Can you explain the significance of that? Why do you need to do that for every calculation that you're doing?
Yes, this is the basic calculator tool that make the comparison and make the calculation and make the calculation. Let's say let's say the first value minus the second value and find the distance. So it is a tool inside Linux that make the calculation and floating point in this scenario.
Okay, so what happens if you don't include that, right? What happens if you treat all your numbers just as like numbers and you don't include the flag L, right, or the BC?
If I didn't include the BC
and the flag L,
it will not give me.
Okay, I think you basically gave me the answer earlier, right? It's basically there to deal with floating points, right? So
Yes.
because when you're calculating and your values are giving floating point numbers, then you have to use the basic calculator and the flag L to allow the computation of floating point values, whereas the default would be to use integer values. So yep, you said it along the way, but it's fine. Yeah.
Thank you.
All right. Anything else that you'd wanna take us through?
I think this project was very interesting, and I hope that all the viewers can benefit from our presentation. Thank you so much. Thank you.
I also I think it was very nice to see that your robot could make decisions quite well, depending on what obstacles was in front of it, and it was not overcompensating. So I would say that was quite nice as well, the way you took into consideration the different index values and the control loop of making that decision. So well done on that one. Now for some general Linux questions, right? Can you explain to me how you send a process in the background, for example, and how would you bring it back?
Okay, I have not used it for a long time.
All right. Yeah. Okay, this was just general, but it's all right. I would understand because it's not really a prerequisite for this project, but it's something that would be important for you to know as you go on.
Yes.
All right.
For sure.
All right. So thank you very much for your presentation, Yousef. So
Thank you.
we'll wrap it up here, and then you just hang on. Okay. All right, everyone. This was Yousef's presentation, and warm congratulations to him, and job well done. So until next time, we'd like to encourage all those of you who would like to come and present their work to do so, and you can also get a chance to showcase your work. So keep pushing your learning.